Okay. Well, thank you, Michaela, and good afternoon, everyone, and welcome to the webinar on the communicative properties of the energy valve. Again, my name is Steve Ripka. I'm the Regional Applications Consultant down here in the southern portion of the United States. For those of you who are familiar with the energy valve, you may recall that with the first revision, you'd have to go into your computer's control panel, go into Manage Adapter Settings, set for a specific static IP address, and then use another static IP address in your web browser to log into what we call WebView or the web server in the energy valve. With the newer revs of the energy valve, you can simply open up a web browser or search engine and type in or just copy and paste the belimo.local:8080 IP address or address and paste that into your browser, and you will be taken directly to the login screen for the energy valve. What you see here is the splash screen or the login screen for the energy valve and the associated passwords. You see we have 3 different levels of access: guest access, a maintenance access, and then an administrative access where we do not publish the password. If you need the password for the administrative access, which you most likely will, you can either contact your local Belimo district sales manager or you can contact our technical support number. One commonly asked question that I guess I'll address now is, can we change the usernames and passwords for the energy valve? Presently, you cannot change the usernames and passwords, so you have to log in using one of the 3 accesses you see here. Once you're logged in, you'll be directed to a dashboard, which is the first screen on the left, and you'll see on the left we have a tree that has multiple screens. The second screen on the tree is what we call the overview, and on the overview page there's some valuable information on the present functionality of the valve. You'll get supply and return water temperature, flow, valve position, calculated WT, among other things. There are also some other pages on the tree to the left. You'll see the settings page, which is very important. This is where the valve is actually configured. There's an override and trending page, also an important page if you need to override the valve for any reason from WebView. We have the status page, a page where you can set the time clock. If the valve is being used for BACnet or being used with BACnet communications, whether they be BACnet over MSITP or BACnet over IP, we have a BACnet addressing page. And then there's also a page where historical data can be extracted from the valve. This data is extracted in either 30-second intervals at 31-day time frames or 13-month intervals at 2-hour time frames. The overview page is also going to include some totalization of some key performance indicators like flow, energy, and whether it be used in a heating or cooling application, as well as power. All the totalized values for yesterday, today, last month, last year, and overall totalization. Power is also represented in maximum peak for yesterday, today, and last month. And you'll see somewhere on the settings page, we can actually display the power in kBTU per hour, BTU per hour, or tons per hour. I mentioned the configuration page. This is one of the most important pages in what we call WebView, or the web interface for the energy valve. This is where the valve is set up. So if you look from left to right, you can see that we have the nominal flow rate of the valve, whether the valve is installed in return or supply of the piping system. The media here is selected water. We can also change that to different types of glycol and the associated percentages of glycol. If you have to change the remote temperature sensor length, so if you have a temp sensor that's either too long or not long enough, maybe it's too long and you need a shorter temp sensor for the remote sensor or the supply temperature sensor. These are all PT1000 RTD temp sensors, so the cable length is critical and cannot be cut. However, we sell or provide the remote temp sensor with different specific cable lengths. If you do go in and change that remote sensor cable length, you'll have to go in and reconfigure it in WebView to get the accurate temperature reading. You can also change some of the measurement units, Celsius to Fahrenheit, GPM to liters, power and energy. Here's where we can maybe change things to ton hours if we choose. We have different control functions that can be selected, so we can start with a standard pressure dependent, or what we call position control. The valve can be configured for flow control, or something we also call power control, which I believe we addressed power control in a different webinar. The control signal can be selected, whether it be 2 to 10 or 0.5 to 10 volts DC, whether or not we want to invert the control signal. So if you want to go from a direct to a reverse acting control signal, that can be done here as well. The feedback position can be set. The feedback signal range can be set. Delta T configuration, whether we're going to use Delta T Manager, Delta T scaling, or something we call power control, that can be set as well. Our maximum flow rate for the valve can be set, as well as our all-important Delta T set point can be selected here. We also have a page where you can look at some historic and live trending. So you can actually go ahead and select specific points and watch them populate on the screen. They will populate for a period of 1 hour. So if you see the points on the bottom of the graph, you can select those, and they will simply start to populate as time runs, and you will get 1 hour of data on the screen at any given time. There's some totalization. So you can look at totalized values for heating or cooling energy, as well as accumulated flow, either for 1 month or up to 12 months. We've added a second y-axis on this graph, so there's more clarity when you look at the graph on the bottom from left to right. And one other thing we can do here on this screen is overrides. So if you choose to override, we have 9 different override settings that you can put the energy valve into. You can go to wide open, fully closed. You can stop the motor in place. You can go to what we call VNOM, the nominal or maximum rated flow value of the valve. Vmax, which is your programmed flow rating of the valve, which for those of you who don't know, with an energy valve, you can program your maximum flow rating down to 30% of its nominal flow or of its maximum design flow rate. Something that will happen if you go into an override mode is we will start to count a timer. And that timer is going to last for 2 hours. Once that 2 hours expires, we will go out of whatever override mode has been selected and into auto mode. So there's no way a technician can go in, override the valve, open, pack up, leave the job site, and accidentally leave that valve wide open, say, for the entire weekend. We will time out, and that will get us out of our override mode and back to auto regardless of what is going on. We have a status page or a diagnostic page where we can look at some errors if we have say a damaged temperature sensor, if there are air bubbles in the system, if the actuator is stalled, where maybe we're not seeing the flow we're looking for at a given position or a given Vmax setting. So all these errors are readable either via WebView on the web page, or they can also be read via BACnet as well as reset via BACnet. I mentioned data logging a little bit earlier. Here we have our data logging page where you can select one of 2 different time frames. So we have short-term or an uncompressed storage, which is going to be 31 days of the data collection selected at 30-second intervals. We also have a 13-month compressed version, or what we call long-term storage, and those are going to be 13-month data files taken at 2-hour intervals. It's very important when you download these files to note that they are short or long-term and save them in different folders, and I'll talk a little bit about that when we get to discussing where they are used in the data analysis tool. You can download and read these in plain Excel language if you want to just open up the spreadsheet, generalize the information, and read them. They can be read if you enjoy chewing on a spreadsheet, but we've also built a tool that we can take a look at the information offline, and that's called the Belimo Data Analysis Tool. This is available either on energyvalve.com, or if you just go to the standard Belimo website and you follow product documentation, it will take you to a location where there's documentation on the Belimo energy valve, and you can find the data analysis tool there as well. So what you'll do is if you've downloaded some files from an energy valve on one of your job sites, and you, of course, have downloaded the data analysis tool, what you'll do is you will open up the data analysis tool on your desktop, and you will select the Import Data button. Then what you're going to do is you're going to go through your file structure and find those CSV files that you've downloaded and stored on your PC. And you will either select a group of short-term data files or a group of long-term data files. It's important to note that we cannot combine the two. We want either short-term uncompressed or long-term compressed data loaded into the data analysis tool. We don't want to combine the two. What will happen is you will import one type of data file or another. It will load up into this Excel tool. And then if you look on the left, we have a little box that says Select Plot. So you can select the objects you would like to look at. Below the data Import Data button, you'll see the data range, which will reference the entire range of the data set that you have loaded up into the data analysis tool. And then you can select duration. And what we mean by select duration is you can select the duration of time you would like to look at on the two graphs you see in front of you. There's also some verbal information on the right-hand side that's going to tell you the control mode the valve is in, whether it's been overridden, or whether delta T manager is active or inactive during a time frame, the installed position, and some averages of flow and delta T. What you do, again, is you select the points or the objects or plots you'd like to look at. They will populate on the screen on these two graphs. You select the duration or time frame you would like on the graph, and then you simply can scroll next time period on the right or previous time period through the overall time frame that is referenced from the data files that have been loaded up into the Excel tool, and take a look at how the valve is performing. You can take a look at how it's performing in relationship to the input from the DDC controller. You can take a look at your measured input and output or entering and leaving water temperatures, your measured delta T. If you're utilizing the delta T manager, you can also see when the delta T manager is or is not activated. Something else the data analysis tool can be used for is plotting the power output curve of the air handler's coil that the valve is associated with. What this will do is it will show you your power saturation point, which is the maximum BTU the coil can yield at a specific flow, and then the associated delta T with that point. This can help make decisions on maybe where we should max out our GPM or our flow rate, and also where we should set our delta T. So a lot of good stuff that can be done through the data analysis, whether it be actually just opening up those CSV files and reading them in plain data format, or loading them up here into what we call the data analysis tool, which is again downloadable from one of our websites, whether it be Belimo.com or EnergyValve.com. We also have another way to access Energy Valve. It's a more simplistic approach. Generally for someone or employee who is not working off a laptop or a PC, or maybe doesn't have access to a PC. So more of a mechanic or a maintenance guy might be able to just carry around this little device here we see on the right called the Belimo ZPH-US. It plugs directly into the Energy Valve, and it can allow you to do a handful of things. And I should note that all the data is on a 2-line LCD screen. So unlike what we've seen in WebView, where we see the entire layout of what's going on with the Energy Valve, you only get a couple lines of LCD data. So you've got to be a little conscientious about scrolling through and just paying attention where you are. But it'll allow you to adjust the Energy Valve flow settings. It allows for an override. If you need to go in and either configure or change the control signal or the control mode, those things can be done. You can select your delta T set point if you're using the delta T manager routine. You can check the sensor status to make sure your flow and your temp sensors are reading appropriately. And very importantly, if you have changed or your customer has gone in and changed the IP address in the Energy Valve's web server and possibly forgot to note that, they didn't write it down, they didn't take a Sharpie and write it on the side of the actuator, if somehow the IP address was forgotten, you can use this little ZPH-US tool to rediscover or discover the IP address that's been programmed into the valve. So the ZTHUS just simply connects directly into this little port on the front of the energy valve's actuator. It slaves the power off of the energy valve, so the energy valve has to be powered up to use the GTHUS, but there are no batteries required, no power supply. So if it's sat in somebody's tool bag for 6 or 8 months and we have power to the energy valve, it can always be used. Another thing, the energy valve is a BTL-listed BACnet application-specific controller. So it is capable of both BACnet over MST or BACnet over IP communications. The BACnet over MST communication is done through a 2-wired isolated network. We have a pink and a gray wire. It is important to note that the pink wire would be the negative and the positive wire is the gray wire. Once in the energy valve, all the MSTP or IP BACnet settings have to be done via our WebView. So you've got to go in, select the belimo.local:8080, log in with the administrative password, and then go to our BACnet settings page. What you see here is the page or the section where the BACnet over MSTP settings are done. You have to select the baud rate. We do not do an auto detect on baud rate. Of course, we want to install an MSTP address and a device instance. If applicable, you can put a device name, energy valve, the associated air handler. And we do have the capability to use a virtual 120 ohm end-of-line resistor. So if in fact your energy valve is located at the very end of one of your BACnet segments and you don't want to use a standard hardwire 120 ohm end-of-line resistor, you can select that box there and use the virtual 120 ohm end-of-line resistor. BACnet over IP addressing and porting can also be entered on this page if you're using BACnet over IP. So generally the port's going to default at 47808. You can select simple or foreign device. Foreign device if you're using a BACnet broadcast management device. The IP address for the BBMD can be installed here as well as that associated time to live. Just a little bit about our PIC statement, which is available both in our communication document and our tech document. The energy valve is a BACnet application-specific controller or a server-type controller. As you can see, all of our rewrite properties are type B. So it is a type B property, BACnet application-specific controller. The supported objects are going to be both analog inputs and outputs, analog values, binary values, device, both multi-state value and multi-state output. So I referenced energyvalve.com in our website. All the stuff I've covered today can be accessed on energyvalve.com or via belimo.us. And the 2 documents you'd be looking for are the Belimo Energy Valve Technical Document, which is a larger document, or if you have communication-specific questions or needs, we have a slightly more compressed version called the Belimo Energy Valve Communication Document, which specifically addresses WebView or the web server access, the ZTHUS, as well as our BACnet functionality. So with that, I think Mikhail will probably take back over and field any questions we may have.
Thank you so much, Steve. So first off, I do want to address some of you were having some issues in regards to seeing Steve's screen. It looks like it had something to do with the type of browser you were using. But as a friendly reminder, we did record this webinar. So after the end of this session, we will be emailing it out to you. Again, my apologies for this inconvenience. So if you do have any questions, there is a question box. I'm sorry, in the beginning I said chat box, but question box in which you can type in your question. I will read it aloud, and then Steve will answer it. You can go ahead and start doing that. I see some coming through. So I'm going to read the first question. What does the Delta T Manager do?
What the Delta T Manager do is going to look at a program or entered set point value for the delta T between the entering and leaving water temperature of the air handler's coil. And if we go below that value by 2 degrees for 4 minutes, or for 5 minutes, I'm sorry, it will incrementally reposition the valve to raise the delta T across the coil and then release back to normal TDC control.
Okay, the next question I have, is this valve POE?
POE. Could I get the detail of that acronym, please?
Sure. Carlos, can you please explain what POE is? And I'm going to move on to the next question, but Carlos, I will come back to you. Next question, does the analysis tool choose a saturation point, or is that done by the user?
Well, the analysis tool can provide you a saturation point, yes.
Okay.
However, if you've got a new piece of equipment, you may want to reference your submittal data for a new piece of equipment.
All right, so thank you everyone for typing in what PoE stands for. It's Power over Ethernet. Is this valve power over Ethernet?
No, I'm sorry, it's not.
Okay, next question. What are the 3 levels of access to the energy valve?
Would that be for me?
Yes, sorry.
That would be guest, maintenance, and administrative.
Okay. Next question. The delta T control still requires a BS2-10 VDC signal to the actuator. That was a question.
Does it require 2 to 10 volt DC signal? Yes, it does.
Okay, great. Thank you. Couple more questions coming through. Does the energy valve provide any alarms? For example, if a coil is fouled or a sensor is not functioning properly.
Yes, it does. All the diagnostics we saw on the status page can be exported as BACnet alarms.
What are the features of guest, maintenance, and admin login?
Guest will basically let you view, maintenance will let you view and make some very minimal changes, while admin gives you access to the entire settings screen. If you're going to do anything in detail, you're going to need the administrative level.
And you can get that password by contacting technical support, correct?
Tech support, or I always recommend your local DSM if you are in direct contact with them in any way.
Okay. Doesn't the delta T manager sacrifice AHU discharge temperature to maintain set point accurately?
No, it does not. Based on how we calculate BTU yield from a coil, there's a common formula, 500 times GPM times the delta T. So if we go beyond our design flow and beyond our design delta T, or below our design delta T, we simply swap the numbers around and still wind up with the same BTU yield. So to say more flow will also correspond with lower delta T, we will not yield additional BTUs. Therefore, we won't have any effect on discharge air.
All right, I will be taking one more question, and then unfortunately our webinar session will end. But if you should come up with another question or you want to bring up a comment, please feel free to email us at marketing@us.belimo.com and we will surely assist you. Okay, it doesn't look like there's any more questions coming through. So once again, thank you so much for participating in today's webinar. Thank you so much, Steve, for doing an excellent job. And we will be sending out this recorded webinar so that you can view it in its entirety. Thanks again, everyone, and we look forward to seeing you at our next webinar. Have a great day.
Thank you, Michaela. I'm just waiting for the request to take over. Okay.